Greetings, sky people. Today I'm going to do a tutorial in PixInsight on how to process a one-shot color image that I took recently. In particular, I'm going to do NGC 1333. Alright, so the reason I picked this data set, I don't actually have a whole lot of one-shot color data sets that I like. This particular image is actually, it's not an ideal data set, but that's part of the reason why I picked it is because most of you are not going to have ideal data sets from really nice telescopes and stuff like that. So this is from a Bortle 7 location, so I have a lot of light pollution. And so I just kind of want to show you what can be done with your images that are maybe not the most pristine data in order to make them look nice, more or less. All right, so let me just go over some basic functionality in PixInsight first to start with. So PixInsight is an extremely powerful image processing software designed for astrophotography. A lot of people like to use Photoshop, and Photoshop has a lot of utility as well. However, it's not designed for astrophotography, and it can be harder to replicate some of the things that we need to do in Photoshop. PixInsight is designed around doing astrophotography and operates on a lot of a different principle than Photoshop, in the fact that it doesn't use layers. And that's part of their kind of operating principle and how they designed the software. Is they didn't want to do anything about with layers, and instead kind of apply these iterative actions. In PixInsight, you have your workspace, and it operates on primarily on processes. There's also scripts that are kind of more like processes in development. So they have them organized by category, but I have an easier time just going to the all processes button, and they're all alphabetical here, all the processes that are available. Just have an easier time finding them. And I've actually, you can save your icons, and I'll show how to do this during the talk. This and with settings that you like. And this is my workspace, so you can actually save out your whole workspace and reload it whenever, and it's got all of the processes that I use with the settings that I like. That way I don't have to go and redo it every single time. So as far as actually using a process goes, there's either 2 or 3 buttons. There's this is the new instance button, and this is what you drag onto the workspace if you wanted to save a particular set of settings, or you can save the process to your computer for use later. I will note that PixInsight, at least on my computer, is sometimes a little bit glitchy as far as it'll kind of freeze sometimes. I'm not sure if that's my machine or if that's weirdness in how they've coded it. Let me mute my phone real quick. Okay, so then the square button is apply. So you can apply that to a single image that's currently open on the screen. The open circle is a real-time preview, so I'll be showing that when we get to this histogram step later on. And then some processes also have a solid circle, which is apply global. So apply global is mainly used when you are applying it to a lot of files that you don't have open in PixInsight. So I'll show you that as we go along. All right, I do want to note, if you're using DSLR images, there is a couple of settings you'll need to tweak. If you go over here on the left to the Format Explorer, and you're going to go to RAW and Edit Preferences and click Pure RAW, and then hit OK. And that's important for if you're using a DSLR, you need to select that so that they get treated properly. As far as data organization goes, I like to organize my files this way. So I have all my light frames here in the lights folder that I've taken. These are all from Sequence Generator Pro. I have my calibration folder that has, actually I'm going to use this other folder I created for this. It has my master dark and my master flats. And then, and I'll talk briefly about how to make those. And then I have my PixInsight folder. So this is where all the processing is, all the like intermediate steps of processing are going to be stored. And then finals, which is where I have the images that I have, like the completed images basically. And this stats file, which is basically a documentation file showing all the information that's important about the image. So the dates that I acquired the images, where I took them, what the object is, the camera and telescope and accessories and mount and all that stuff, how many images ended up making it into the final image, what software I used to process, how many darks, how many flats, the temperature and stuff like that. And then I also keep a list of all the steps I did in PixInsight, so that if I go back and reprocess it in the future, I can see what I did originally and what I could do different when I have different or better knowledge of PixInsight. This is with the ZWO ASI 294 MC Pro camera. So this is a color camera, one-shot color camera from ZWO. This is on my Takahashi refractor, using a CLS CCD filter, which is a light pollution filter that also blocks UV and IR, on my Celestron AVX mount, which really doesn't track very well at all. And then these are the two, like the guide scope and the guide camera. Alrighty, minimize that. So let's start by just looking at one of the subframes. So when you initially open a raw image in PixInsight, there's a couple of things that might surprise you, especially if you're used to using, if you're coming over from a DSLR and you're used to just looking at raw images in Photoshop where they're already stretched. First of all, it's really dark because the data is still in its linear state and it's being shown in its linear state here. Second, the image is black and white. And that's because we have not yet debayered it to take the raw pixel by pixel information and convert it to what the colors are that each of those pixels represents. So in PixInsight, you can apply a screen stretch where it will make the image more easily viewable, but doesn't actually change the image data. So if it's not there, you can go to process, all processes, and open, it's called screen transfer function. And hit the little nuclear button and it will do the auto stretch. So this is the auto stretch. As you can see, it's still black and white, and you can see our Bayer filter, our Bayer mask here, which is the red, green, green, blue pattern of the color pixels on your camera. So if you want to just preview the image and see what it looks, what like one of the single raw files looks like, but you want to see it in color, you can go to the debayer process. Now you do have to know the Bayer pattern of your image. A lot of cameras are RGB. If you're not sure, you can Google it and see what the manufacturer says, or you can just try each of these and then see when it looks not weird. So I'm going to hit the apply button since it's a local image that's already here open in PixInsight. It's going to debayer it, and then I'll apply the auto stretch, and now we have a color image. And as you can see, there's not really a whole lot to see here, and that's going to be the case a lot of the time with astro images, except for maybe the brightest targets like M42, the Orion Nebula. You're oftentimes not going to be able to see the target very well at all. And don't be too freaked out by that, because as you will see, the magic of stacking really brings out that data that's right now, it's very close to the noise. But when we stack, statistics helps us pull apart the coherent signal from the incoherent noise. So this is what a single subframe looks like. Pretty awful, and that's why image processing is so powerful and needed. The very first thing you'll want to do is to blink through all of your images and delete the bad ones. So there's a process called blink, here. And this is just a quick and easy way to preview your data. So I'm not going to open all of these right now because it'll take a bit to load, but I'll just load some of them so I can show you what I mean. If you have a DSLR and the data is in the header on what the Bayer pattern is, this will automatically debayer the images for you. I haven't figured out how to tell Blink what the Bayer pattern is if it's not in the header, so these images are black and white. But you don't need them in color to be able to go through and tell whether the stars are skewed or not. So I've already gone through and culled this data set, so all the stars are going to be pretty well shaped here. But this is where you'll want to delete images where the stars are weird shapes or streaked, or you had tracking errors, or if you zoom out, I'm using the mouse scroll wheel to do the zooming here. You can go through and delete ones where there's obviously clouds rolling through or tree branches or stuff like that. The easiest way to delete them is to hit this Move Selected Files to New Location button, and I just created a trash folder since I can't actually select the recycle bin from here. And I just move them to this trash folder and then later on empty out the trash folder into the recycle bin. Quick and easy way to delete the bad images. Yeah, so after you've gone through all of your images, the next thing to do is, if you don't already have your master dark and master flat, then you'll need to create those. So if you're using a CMOS camera, you don't need bias frames. They tend to actually cause more problems than they help, because it's really hard. You can't really get true bias frames on a CMOS camera because of their architecture. But you can, that's pretty well taken care of with the dark frame. Some people do flat darks as well in order to denoise their flat frames. I haven't really found that to be necessary, so I haven't really used them much at all. And what that is, so your flat, let me back up a little bit. So your dark frames are a type of calibration frame that helps with denoising your image from the sense of what the camera adds to the image to some extent. So any type of camera sensor is going to add some inherent electronic noise and noise from heat as well, especially as it warms up while you're operating it. And now noise is random, so you can't truly subtract it out, but you can average a bunch of frames that capture that dark signal and subtract that out, and that kind of helps lower the overall noise level of your image. Dark frames need to be taken at the same temperature and the same exposure time and the same gain as your light frames. And then flat frames help with vignetting at the corners of your image, as well as dust bunnies is really where they help the most. It's inevitable that you're going to get some little dust motes on your filters or on your telescope objective. So the flat frames help to capture that. And there's several different ways to take them. Sometimes I take twilight flats where I just turn off the tracking on the telescope, point at a clear patch of sky, and set the so what you want to do for flats is, the important thing is to have the exposure time set so that the histogram is in the middle, so the histogram peak is in the middle of the histogram. Let me show an example of that. So here's one of my flat frames. It's not debayered, so it's kind of hard to see any of the, like there's some dust bunnies there. It's more obvious to see it when I actually debayer it. Actually, I'm just going to go ahead and debayer it so we can look at it. Yeah, so you can see that it's kind of blue, which doesn't really matter what kind of the overall color tint is, because the yeah, it doesn't end up mattering. You can see all my dust bunnies here and a little bit of vignetting. And then if we go to the histogram, you can see that so there are three different, the red, green, and the blue peaks here. The SharpCap software that I use to capture these images also shows kind of the summed peak, which lands right about in the middle of the histogram here. And that's what you're going for with your exposure times on your flats. Yeah. Okay, so I like to take, you need like a minimum of 20 darks and 20 flats. I tend to do like 100 darks and 50 flats, higher quality, statistically speaking, image. So to stack your darks that you've taken into a master dark, you're going to use the image integration process, which again is under processes, image integration. I just have it saved out over here because I use different settings for it than I do for stacking lights. You will add your dark frames. I'm not going to actually do this here, but you go to where your dark frames are stored, you select them, add them here. Now the settings I use for this, and for a lot of these processes, I got from the Light Vortex Astronomy tutorial series on PixInsight, which is free, and it's a written tutorial. It's got tons of screenshots, and is really well done. And I've gotten, that's pretty much how I learned PixInsight, was from the Light Vortex Astronomy website. Highly recommend. So I used the settings that they recommend on there as far as the combination is average, no normalization. The rest of these are pretty much defaults. I use linear fit clipping since I have more than 20 frames. If you have fewer than 20 frames, you'll want to use Windsorized Sigma clipping. What the clipping does is it's rejecting things that are not in every single frame. So if you're doing twilight flats and you've got stars that streak across your frame because you're not tracking, then those get rejected because you don't want stars in your flats image. It rejects cosmic rays. The other way I do flats is I just throw a t-shirt over the objective and do it during the day. And those tend to be a lot shorter exposures, which can be problematic, but they've worked all right for me most of the time. But yeah, so the rejection algorithm helps with star trails and cosmic rays and things like that that are not in every single frame. And you'll hit apply global, it'll go through and integrate the image, and then you can save out that image as your master dark. Flats, to make your master flat, you're going to use the same process but with some different settings. Again, I pulled these from the Light Vortex Astronomy website. Average in combination, multiplicative in normalization. I don't know a whole lot about what the normalization setting does, but just kind of went with what was recommended on the Light Vortex website. Selected these options that I'm showing here. And then for reduction algorithm, I guess percentile clipping works better for flats, equalizing fluxes for normalization of the pixel rejection, and the settings here. And the rest are pretty much left at default. I add my flats files, make the master flat, and that's that. All right, so at this stage, I've got my master dark. And now the reason I have 4 master flats is because every time you change telescope configurations, like if you set it up, image at night, and then take it apart and bring it back inside your house, or if you're out at a dark sky site or something, you're never going to get that camera lined up exactly the same every time when you put the system back together. So those dust bunnies are not going to be in the exact same spot. So every time you disassemble and reassemble your rig, you need to take a new set of flats. So I organized mine by date, and that's why I have 4 of them here for different date ranges when I had my setup, and then other times when I had to swap the cameras back and forth and stuff like that for various virtual star parties. So that's why I have 4. Okay, this is a lot of like the nitty-gritty work that you have to do at the beginning before you can get to the fun stuff. So just bear with me. So it's the master dark and master flat. Now that you have those, you can start to calibrate your lights. So for that, we're going to use the image calibration process. which I've got one with all my settings over here called Lights Cal. So I'm going to add all of my lights. I'm going to untick Enable CFA just because, so CFA has to do with the debayering that I talked about, but it's given me some issues because my Bayer pattern's not actually stored in the header. It just causes some random errors and stuff, so I end up disabling it. Yeah, okay, so I select the output directory. So make a folder called, so I put numbers in front so I can have every step be in order when I go through and look inside this folder later, like especially if I have to backtrack steps, it makes it a lot easier to backtrack. So I'll call the folder 1 calibrated. I add the master dark under master dark. Now if you have different temperatures or different exposure times of images and stuff like that, you'll need to split up your images by what's going to match the dark and the flat. And actually I need to do that here because I have my, my flats at different date ranges as well. So the first date range on the flats, October 15th. So I'm going to select my lights that I took on October 15th. Now, I didn't actually end up with usable flats for all my dates in here, so we're going to have to do some stuff to kind of flatten those images later. So I only have a couple from the 15th. So I'm going to select those, select the calibration, the master flat, hit apply global. All right, now the 20th through the 30th of October and the corresponding flat. Now I have a home-built desktop that's pretty beefy, so a lot of these processes will probably work a lot slower on your machine unless you also have a beefy home-built rig. I have 32 gigs of RAM and like a 16-core processor, so it tends to rip through these processes pretty quick. All right, the next one is November 7th through the 8th. So I'm looking at the date modified over here. All right, and finally, I have a set that I don't have flats for, unfortunately, so I'm just going to untick master flat and just do the dark calibration on those. Now, as a note, my flats kind of stopped working in PixInsight about 6 or 12 months ago, and in order to make them work again, I kind of had to do something weird, because what was happening was my flat started overcorrecting, where my dust bunnies became little bright spots, and the corners with the vignetting started to become bright corners, and it was very weird. I never really figured out why it was doing this, but what I did to fix it, in case you run across the same thing, is I opened up the original flat, the master flat in PixInsight, and then let's see, for my color camera, I just add a global offset to it. And I had to play around with this exact number to see what was going to work the best. But for my color camera, it worked out to be an offset of 0.15 to make it actually correct the flats, or do the flat correction correctly. And on my monochrome camera, it ended up being this value. So if anybody else has that problem, that's one way to fix it. Don't know why it started doing that, and it's a very weird thing to have to fix, but yeah, so all my flats have already been, that offset has already been added. Okay, so now that we are done calibrating all the lights, now we can go on to the next step, which is SubframeSelector. Well, a quick note on calibration. You don't have to do calibration. You don't have to have darks and flats and whatnot. However, it's going to greatly improve your image quality. So it's not a required step, but it's a very, very helpful one that pretty much everybody does. This next step is also not required, but can help you cull down your images to get the ones with the best shaped stars, which means you're going to have the best clarity on the actual deep sky object that you want. So this is a process called SubframeSelector. And so the first thing we're going to do is we're going to measure all of our subframes. So I'm going to go to Add Files, and we're going to want to do the ones that we just calibrated, which now have a little _C after them. And we can do all of them at once because now that they're all the same. They've been calibrated with the master dark and the master flats as applicable, and we can do this all at once. Now, when I am doing monochrome images that are not one-shot color, I'll do this with all the luminances and then the reds and then the greens and then the blues. I'll have to do another one of these tutorials for how to do monochrome image processing. But for the one-shot color ones, I can do them all at once. There's a little bit of calculation that needs to be done for this. So your subframe scale, this is the arc seconds per pixel resolution of your camera plus your telescope. You can get this value by going to astronomy.tools/field. The exact link. If you just go to the astronomy.tools website, they have a field of view calculator. And you choose your camera and your telescope, and it will tell you a bunch of useful information, including what your subframe scale is in arc seconds per pixel. The camera gain, sometimes you can find this number from the manufacturer or from other people who've tested it. There is a process, or a script rather, in PixInsight to measure this. This I think is a measured value for my monochrome camera actually. For the color camera, the value, this is one that I pulled off the manufacturer's site, I think. Yeah, so you have to either look it up, or I'm not going to go through how to do that script, but there's websites that talk about how to measure what your gain is. I know my camera is 14-bit. I don't worry about the site local midnight thing. Sorry, just having the dual screen set up is making things weird. Then I choose where I'm going to output my files to. I'm going to make a folder called 2, approved, put them there. And for routine, we're gonna measure the subframes and hit go. Okay, so on SubframeSelector here, it's finished analyzing all the images, and it's going to produce actually several graphs, depending on what you want to look at here.
It's like we want it to be near the line.
No, the line is the average, I think.
Okay.
So what you're gonna want to so let's look at eccentricity first. So I did a little Googling, and as far as eccentricity goes, apparently a perfectly circular star has an eccentricity of 0.42 or something like that. And the higher above that you get, the more elongated the star is, more or less. So
wow, mine would be like
yeah. So I mean, so there are like you know, I could make a cut on 0.5 and have a lot of really good looking stars, but I would also lose a lot of frames. Kind of want to balance out the number of frames that you keep so that you have a good quality stack where you have enough frames to have a good signal to noise ratio and good a nice looking image and stuff like that. But you can also degrade your image by leaving in too many frames where the stars are elongated or a little bit blurry and stuff like that. So you're kind of doing this balancing act between the two of them. So I kind of tend to eyeball my cuts for this, mainly to kind of balance how many frames I cut versus how many I keep. So a quick and easy way, especially if you have a lot of frames, like here I have 163 subframes, a quick and easy way is to use this SubframeSelector expressions box. So I'm just going to type in, so the value is eccentricity, and so you can just type in that actual value, and it will know what you're talking about. Now I'm going to do, well, 0.6 really isn't too bad, so I'm going to go ahead and set that at 0.6. And this is what's going to be kept. All the frames that have an eccentricity of less than 0.6 are going to be kept. The other one I look at is full width half max. Full width half max is basically the size of the star in your image. And you'll have a larger full width half max if you're out of focus or if the seeing was really bad, and a smaller full width half max if the seeing was good and you're in focus. Now the actual value of the full width half max is completely dependent on your camera and the telescope that you use, or the camera lens that you use. So don't read too much into the actual value, because your values will be different. But here I know that this really high value of like, what is it, 10.7, that's like a probably pretty blurry frame. And kind of looking at the spread of the data, I think I'm going to go ahead and set that to be, I'm going to reject ones that are greater than 8. So I'm going to type in full width half, actually, I need a double ampersand, full width half max less than 0.8 is what's going to be kept.
All coding in here.
I feel like, am I smart enough to use PixInsight?
Yes.
I don't know.
Guys, I'm using less than symbols and ampersands. I think you're going to be okay. And let me explain the full width half max thing real quick, and then I'll take the question.
Because I was totally like drawing a blank just even saying the word.
So here's a Gaussian of, let's say, like a star, and here's another one.
Okay.
Full width at half maximum. So you go to the halfway point, which is about here, and you measure the width of the peak. And that's your full width at half maximum. And this is going to be some number of pixels. And then over on this peak, this is about the halfway point here, and you're going to measure the width of the peak. So this is going to have, like, I'm just going to throw an arbitrary number on here. Let's say that the full width half max on this one is 3, and the full width half maximum on this one is 10. So if this was a star in your image and you're looking at the profile of its brightness, this is going to be a nice in-focus star, and this is going to be like an ugly defocused star. Does that make sense?
Like my stars. This is Diana's star, and this is Molly's star.
Oh, believe me, this data set was originally over 200 frames, but I had to drop about 40 of them for bad tracking and not being in focus. And actually, I've dropped even more of them. It's just this data set was probably originally 350. So.
There's a quick and dirty way to stack and calibrate that I found online under batch processing.
Yes. I am not showing batch processing just because I wanted you to see all what happens during batch processing. I kind of want to show.
So she's showing like if you're the kind of person who needs to understand why this is happening, she's showing like this is, yeah, I get what you're doing. You're like building an understanding of how it works.
Yeah, because weighted batch preprocessor does all of these same things, but it does them all at once.
That's the one. I see.
And a lot of people use that. I don't, just because I like to. I've had an easier time, just especially when I have many nights worth of data. You can parse out multiple nights in weighted batch preprocessor, but I think it's almost faster for me to just go through and do it myself. Then is I'm gonna continue showing it this way, but then before I stack, I'll do a quick walkthrough of weighted batch preprocessor, and that's what you can actually use.
Cool.
Yeah, so I'll go ahead and do that so I can kind of show both. Okay, so this really ugly equation down here.
That's yeah.
I didn't realize this was a math class.
Yeah, so there's approval and there's weighting. So approval is so like if I'm gonna collapse this again real quick. We've winnowed it down to the best 103 out of 163 frames. Yeah, so this is cutting out all the frames that we've deemed to be of a lesser standard. Now, this weighting algorithm, when you go to stack, you can just average all the frames and give them all an equal weight, or you can you can weight your frames in that stack by how good they are. And this long equation here is pretty much doing just that. It's applying a higher weight to frames that have a lower full width half max, so stars that are nice and little. It's applying a heavier weight to frames that have lower eccentricities, so more circular stars. And it's applying a heavier weight to frames that have a better signal to noise ratio. And that's basically what this whole long equation is doing. Now this equation, I didn't come up with this. I pulled this off of the Light Vortex Astronomy website, and you can just literally copy paste it from his site. Okay, so I'm gonna go ahead and run SubframeSelector here. It's gonna write out all the frames with the ones that we've selected based on their eccentricity and full width half max and the weighting algorithm. And with the new weighted batch preprocessor, you can put that weighting algorithm into weighted batch preprocessor now, but you kind of have to do it as a GUI and as opposed to putting in this nice easy function here. If you, I have these in order by their weight, so I'm going to go to the what you can do here. Go to the highest weighted subframe is frame 257, and that's what I'm going to use as the registration reference. Okay, so that's done. Now we're going to debayer them. So now, because they're still black and white, we got to get the color. So I've just went through and selected all the ones that we just approved. I'm going to make a new directory and just hit apply global. So now our images have been debayered. So we can go ahead and open one here and just double check it. All right, so you can see that my dust bunnies are pretty much gone because flats are awesome. We have a nice color image and nothing looks like anything crazy happened. So. So now we're gonna do image registration. So that's gonna align all the images basically. 257. Close out of SubframeSelector. Making sure I'm adding all the ones that we just debayered. And then make another folder called registered.
What is debayer? What are you doing?
That's where you're turning it from a raw image to a color image.
Oh, okay.
All right, and I pretty much use all the defaults for this. The only time I change any settings in star alignment, which is the actual name of the process, is if it's having a hard time registering frames, like if all my frames have bad stars, but I'm going to stack it anyway, then I'll go through and increase the ransack tolerance or some of the other settings. This Light Vortex tutorial kind of talks about what you can tweak to get your images to register. But if your stars are pretty decent, then it's going to be able to register them and do the alignment process. So what you can see here is on the in the dialog box here, it's actually showing how it's rescaling sometimes the images, how it's translating them and rotating them to match up with the reference frame. Because it can handle all three of those things. It can translate, so it can move the frame around. It can rotate, so if you like, it takes care of meridian flips, and if you like took your camera off, put it back on, and it's like in a different orientation angle, or even if you use different scales, like on some images you have a focal reducer and some that you don't, it can handle that as well. And even if you use different telescopes, it'll register all that data together, which is really cool.
Really, I always wondered about that, using different telescopes for data.
Yeah, because all what's gonna change there is the the orientation, so the angle and the scale of the image, and it can handle can handle the scale as well. All right, so now it's time for stacking. So we're going to go to our registered images.
How many images?
This ended up being 103.
Okay.
So the settings I use here are, again, from Light Vortex Astronomy. We're going to average them. For the normalization, he suggests using additive. Now, we did that weighting in SubframeSelector. And this is why I like using SubframeSelector instead of WeightedBatchPreProcessor, because I can save that as a fits keyword that I've called SS weight, SubframeSelector weight. And I mean, WeightedBatchPreProcessor, I guess, does this now as well, although I'm not sure how much you can tweak what that weighting algorithm is. Yeah, for pixel rejection, because I have over 20 frames, I'm going to change this to linear fit clipping. And Diana, since you weren't here, the rejection algorithm is what you use to get rid of satellites, airplane trails, and cosmic rays. So if it's not in every frame, then it will get rejected, basically.
Oh, cool! I love that.
Yeah. So don't throw away your images that have satellite trails and airplane trails and stuff, because you can still stack them. All right, so it's done doing all of the whatever it does in its first step, and now it's actually doing the image integration. Because this is a color image, it has to do it 3 times, once for the red, once for the green, once for the blue. And this is the part where if you have a computer that's not, doesn't have a lot of CPU, doesn't have a lot of processing power, then it can, this is the part that can be the slowest. So as you can see, this is a pretty CPU heavy process and also pretty memory heavy process. Now I do have a lot of applications open right now, but it is using quite a lot of RAM. Yeah, you can see it's using 13 gigs of RAM right now, and so like a lot of processor and a little bit of my graphics card, is actually a fair bit of my graphics card as well. Actually, a lot of this graphics card is probably me recording over in Streamlabs.
So you have 100 or so images stacking. How long does that normally take?
Oh, it's done.
Oh, it's not. Oh, nice.
It strongly depends on your computer.
What's all that?
Okay, so what we have here is it produces a couple of images. Since I chose linear fit clipping, it puts out this slope frame, which like doesn't. It's just.
Ooh.
It's just showing. It's not anything important. Rejection high is showing the high end of what pixels that were rejected. So this is where you're going to see like satellite trails and you can see an airplane trail over there and stuff like that. Rejected low is basically like the low end of what was rejected, which is mostly like some noise pixels and cosmic rays and stuff like that.
Yeah.
And finally, here is the integrated image.
Oh, look at that! It's awesome. So this was shot over how many nights, Molly?
Oh, a lot.
That's why it looks all funky, right? Because your camera was different.
Yeah, yeah. So here's all the nights it was shot over.
Oh, Nicole's just like, I'm done. I need one. I want like. I think I'm impatient. I want like one night. I want my image.
Oh, I used to be the same way, but now that I have a backyard set up, I can just kind of take my time and sit on a target for a while. Okay, well, let's keep moving on because I know not everybody has an entirely free day like me right now. So, first thing I'm going to do is crop out all of the stacking overlap edges. So
if you can keep that thing on the upper right, that looks cool. Is that looks like a galaxy? I don't know what it is.
I think it's actually just a star with some reflection nebula around it, but it might actually just be artifact. I haven't really looked at that star real close yet to figure out what it is. Yes, I'm using dynamic crop for this.
Nice. Ooh, looks great.
Thank you. All right, now, this is what makes PixInsight worth the money. One of the 2 processes that I say makes it worth the money, and this is dynamic background extraction. The main things I mess around with here is the default sample radius and the samples per row default sample radius, I tend to leave at whatever PixInsight guesses it should be. Samples per row, depending on the nature of the gradients in the background, I'll either increase or decrease this number. I'm going to do 8.
Molly, I can't read what process you're using.
Sorry,
What
yeah,
is it called?
thanks for reminding me. This is dynamic background extraction.
Okay, so this is the first step that you do to process.
Yeah, after I've gotten the stack, and after I crop it, this is the first thing I do to the stack, yeah.
Nice.
After I'm going to choose 8 samples per row just because the gradients are pretty large on this. So I'm going to hit generate, and I'll show what that did in just a second. And for the target image correction, there's a lot of debate as to whether subtraction or division is better. I tend to do subtraction if I'm doing it before I stretch it, and division if I do this again after I stretch it. So I'm going to zoom back out here. So you can see we have a multitude of sample points here. Now you can do automatic background extraction, but I tend to find I don't like the result as much, although you're free to mess around with it. So now the downside with this is the longest stuff actually, as far as hands-on work, is dynamic background extraction, because you have to check all your sample points and make sure they're not sitting on top of stars.
Okay.
So I'm gonna go through and just try and do this quickly.
So why can't they be sitting on top of stars?
Because then the sample point is gonna, because what you're trying to sample is the background, and you're trying to remove this background gradient. So you don't want stars in there because it's gonna get a bad reading of what the gradient is. And you also don't want any sample point sitting on top of your target. Usually PixInsight's pretty good at estimating where your target's at, based on how rapidly the background changes over the size of your sample. But sometimes if you have a big extended nebula, or a lot of like tidal streams coming off of a galaxy, you have to go manually delete those points. And you can just click on a point and hit the delete key to remove it. So I'm clicking on each of these sample points and just clicking and dragging them to get them off of stars. Now, what I'm looking at when I'm doing this is this little box over here. It's showing an inverted view of what's inside of that sample point. So you can see this is what a star looks like. If you're doing a monochrome image, it'll be a black and white image, and then a color, it's showing inverted color here. The other parameter I mess with is the tolerance. And it kind of provides a tooltip description of this one. Yeah, you probably can't read that, but in PixInsight, if you hover over anything any settable values, it will give an explanation of what that is. They don't have like a documentation document per se. All the documentation is kind of like at where that step is at. Okay. So I've checked all the sample points, moved the ones off of stars. I'm going to lower the tolerance to 1 and hit resize all, so that, I mean, this is kind of a guessing game. You don't want to go lower than 0.5, but I'm just going to set this to 1 and roll with it. Usually I make a new instance, click and drag, so that I can save out this DBE process, so that if I go back and do it later, I don't have to redo all the points and stuff like that. So I'm going to right click on that. Click Save Selected Icons. I save it to the processes folder I've made here. Yeah, so now I can reload this process later if I decide I want to go back and do it differently and not have to readjust all the sample points. All right, now we're going to hit Apply. This happens really fast. And it gives you 2 images. It gives you your background, which is subtracted out. That looks pretty much like how the background looked. And here is the subtracted image. Isn't that amazing?
Oh my god.
That's one of the things that makes this worth every dang penny.
Please.
All right, so I'm going to close that. I can close this image. Well, okay, so I save, since there's no layers in PixInsight, I save images as I go along. So I'm going to save out my stack here, my stacked image as XISF is like PixInsight's file format that has all the it's got the most amount of information that it stores with it. So I'm going to call this integration. Save it out as its default 32-bit. And now we can close it. And I'm going to save this out as well as DBE. Okay, now you can see that it looks noisier, and this is because we've removed a lot of the background, so now we're hitting the noise floor. But we're going to deal with the noise next. So to deal with the noise, we're going to use a process called multi-scale linear transform, which can be found again in processes, multi-scale linear transform. Now I've got a copy of this with I have all of the settings I like to use for the denoising mode, and these exact values can be found again on the Light Vortex Astronomy website. This is precisely what he recommended, and I've actually found it's worked really well for me in all my images. Okay, now when you're denoising, you can see here that the brighter areas are less noisy and the darker areas are more noisy. And denoising is basically all it's doing is it's putting a blur on across multiple pixels so that the noise is less obvious. So you don't want to blur your target because you're going to lose detail on your target. So what we're going to do is we're going to apply a mask, and you can do the masking in Photoshop as well. I'm going to hit this extract luminance component, and here's the auto stretched version of what that looks like. So this is just pulled out the luminance here. I'm going to minimize this window real quick. Now masks need to be non-linear. They need to be stretched in order to work properly, and there's a quick and dirty way to stretch images without having to go through and do it by hand. Okay, so if you open the screen transfer function process and the histogram transformation process, go back to the extracted luminance channel. I'm going to hit the nuclear button, and it's going to auto stretch the image. Then I'm going to click and drag this new instance icon, the little triangle, click and drag it into the bottom bar of the histogram transformation process. And it's going to take that stretch and copy it into the histogram transformation process. Then I'm going to reset the screen transfer function and close it, and then hit apply, the square button. And that's going to permanently apply that stretch to the luminance image, which is what we need it in order to make it a mask. Okay, so this is now a stretched image. We can minimize that. And then I've put the mask toolbar on my icon window here for easier access. You can also just hit select mask here under the mask menu. I'm going to select that stretched L image. I'm going to hit invert mask. So all of the red areas are protected, and the less red areas are what we're going to attack. You can, under the mask menu, you can click on show mask, and it's still there, and you know that the mask is there because this tab is orange, but this way we can actually still see the image. Okay, going back to multi-scale linear transform. I'm going to zoom in so you can see what happens when this is applied. Yeah, so now we have the mask on. We'll open up multi-scale linear transform with all of these settings here that I showed earlier, and I'm going to hit the square button to apply. And it's going to think. And there we go. So I'm going to zoom in and blink back and forth so you can see the denoising.
Oh, very cool.
And I'll go out to one of the darker areas here. You can see how much is
you can really
denoised.
tell.
Yeah.
Wow.
Okay, so we can close multi-scale linear transform, and you can remove the mask by going to mask, remove mask. Our tab has gone back to being not orange anymore. Now we're going to do my other favorite process in PixInsight, which is photometric color calibration. So different ways to do color calibration in Photoshop. When you hit like the auto color button, it'll take an estimate. That estimate's usually wrong. There's a couple different color calibration processes in PixInsight, but photometric color calibration is hands down my favorite. So I'm going to open up one I already have over here. So there's only a couple things you need to mess with here, which is primarily, so what this is going to do is it's going to plate solve your image so that it knows what part of the sky it's looking at. Then it looks at the APAS catalog of stars and finds a sun-type star, a G2V star, and it uses that star as the white reference so that it'll color the image that's in a way that is like how our human eyes would perceive it, because we've evolved to have our color spectrum match that of the sun. It's really cool. So I find this gives pretty accurate color the majority of the time. So I'm going to go to, you don't have to type in the coordinates, it has a catalog search. So NGC 1333, I hit search. Yeah, so I'm just like, I typed in the target name, I hit search. It knows both common names and catalog names. So if you type in like Trifid, it'll find that as well. And hit get. And then you do have to set your focal length and your pixel size, because it needs to know those things in order to plate solve the image. So my focal length is 530 millimeters, and the pixel size on my camera is 4.63. This is in microns. You can find that value on the manufacturer website. Everything else I leave as default. Let me get out of the magnifier mode here. And I hit go. Now, since I had this image auto-stretched, PixInsight took a guess on what the color balance was. So you're not actually going to see a whole lot of a difference. But after this process is done, I'm going to show you what the colors of the image actually looked like raw, like without the estimate that screen transfer function takes to do the auto stretch, and you can see how much good the photometric color calibration is doing. So it produces these B minus V and Sloan R minus V plots these are basically just color plots of the stars in the image. They're not important, they're just kind of informational. And we have our new image, which looks a lot like the old one. Before we did dynamic background extraction, and I link the color channels, you'll see that the image is largely blue. And this is because I'm using a light pollution filter that kind of gives it a blue cast. So dynamic background extraction took care of a lot of this, and then photometric color calibration took care of the rest. Some images, this process appears to do a lot more than others, but now we know that our colors are balanced in such a way that it's a pretty accurate color representation of the image. All right, so we can close photometric color calibration. Now again, you can see that there's a ton of noise in this image and the background is really high. That's because screen transfer function is it kind of overstretches the image so that you can see everything that's going on. So don't get too freaked out at how gross and ugly this image is. We will shortly be remedying this. Okay, now I'm not going to go through, there's another process I sometimes do at this point, which is deconvolution. Deconvolution works really well for images that have a lot of detail, like some of the richer nebula and galaxies and stuff. It requires that you have a lot of frames in order to make it work out well, and even though I have a lot of frames in this image, with my heavy level of light pollution and all the noise that's in this image, I don't think deconvolution would work very well. Plus, there's not a ton of detail to bring out anyway, because a lot of this image is dark nebula. All right. So since we're not doing deconvolution, at this point, we're pretty much ready to go ahead and apply a stretch to this image. So I'm going to show graphically what I mean by a stretch. So first, let me remove the screen transfer function. And I do two different kinds of stretch. But first, I want to show you what the histogram looks like. So this is the raw histogram for this image that we're at now. And I'm going to zoom in here. on the left side of the histogram, and this is where all of our data is, in this tiny little peak way over here on the far left side. That's why the image looks so dark. It's on a histogram. The left side is basically, if this was on a scale of 0 to 1, 0 being black and 1 being white, this is showing how many pixels in the image have that brightness value. So since the raw image without the screen transfer function is mostly black, all the data is down here at the far lower left corner. And that's why it looks black, is because it's all way down here. Stretching is you're literally kind of redefining what the brightness values are in your image so that this histogram takes up of this peak, becomes wider and moves to the right so you can actually see it. So let me zoom back out here. So we're going to open up, actually before I do that, in order to maintain the star color, I've used a process called ArcCinch Stretch. This is up in Processes, ArcCinch Stretch. I set the stretch factor to be about 4. And this part's not mandatory, but I found it helps to maintain star color. I'm just going to apply it a couple of times. And it's going to just do some little stretches. And this will kind of help maintain the star color. Now, if you don't want to do that, you can just totally skip that and go straight to histogram transformation and open up the live preview, which is this open circle on the bottom. This will so in Photoshop, when you are when you have like the histogram like the levels window open, it'll kind of apply it live to the image. PixInsight doesn't do that, but it has this live preview, so you can know what you're going to do before you actually apply it. So histogram stretching, you're going to do lots of little steps. So first, I'm gonna take the midpoint slider and move it to the left. Not all the way, because I don't want to, like, stretching is best done in several iterative steps. So I'm going to move it to about, I mean, this is kind of touchy-feely. There's no like real algorithm for this. So I'm going to move it up to there, hit apply, hit reset. Processes in PixInsight are iterative, so you have to reset them every time you are going to apply the next step. I'm going to take the black point slider, move it up, not quite to the foot of the histogram, most of the way up there, then take the gray point, slide it to the left, apply, reset. I'm just going to keep doing this, moving the black points, moving the midpoints. Do this 3, 4, 5 times. And then finally I'm going to kind of end by moving the black points right to the foot of the histogram and bringing up the midpoints just a hair. Alright, so now you can see our histogram is instead of being all over on the far left side, is in kind of the first quarter to first third of the histogram, and you can see that it's a lot wider now. And this is, now our image is nonlinear, it has been stretched. And we can actually see what's going on here now without the aid of screen transfer function. And from here on out, it's a lot of prettification. So this is just whatever you're going to do to make the image look nice. So I'm going to open up curves transformation, which is a lot.
My favorite part.
Yeah, it's just like curves in Photoshop. Again, I'm going to open up the live preview here.
Mm-hmm.
And you can even, if you hit the little check mark, it'll show you your histogram.
Oh, yeah.
I'm going to bump up the midtones and kind of drag down the darks a bit more to kind of kill that background a bit more. Hit apply, reset. You can also adjust your saturation here. But I don't want to bring up the saturation of the background because the background is got a lot of messiness in it. So what I'm going to do is I'm going to let's see. Yeah, I'm going to use range selection, which is another process. Hit the live preview button, and I'm going to use this to select kind of on a brightness scale of the image, and I have this fuzziness set to 0.15 and smoothness to 5, so I get a nice kind of smooth transition in the mask. And I just drag this slider until I kind of capture the areas that I want to adjust the saturation on, and the black is where I don't want to adjust the saturation. And I hit apply. And I get a nice range mask here, which I'm going to minimize. Apply to the image. Look at it, make sure I've got it in the right polarity. Yeah, so the black areas are protected, and the white areas are what's going to be attacked. So let me turn that off. So then this way I can adjust saturation of just the nebula and the stars and not the background. So I'm going to bump up saturation on the nebula. And I can invert that mask so that it protects the nebula and the stars, and then I can desaturate the background. So that I don't have as much color noise in the background. Apply. Alright, so now we're here. Now I want to deal with these leftover dust spots from the couple of nights that I didn't have good flats for. So I'm going to use a process called clone stamp.
What that is. Oh, okay.
Yeah, those are just dust spots.
Okay, gotcha.
Normally those taken care of with flats, but Diana, you missed at the beginning. I didn't have flats for every night that I had data for. So I had some nights where I still got some dust spots coming through. So this clone stamp is exact. Huh? What do you say?
You can get rid of those?
Yeah.
Really?
Yeah, so you can get rid of them with flats, or you can use this clone stamp process here. The important thing with taking flats is that you need to have your camera still be in focus from the night before, or else you're not going to see, or close to focus, or else you're not going to see your dust bunnies. This clone stamp process is exactly like the one in Photoshop, where you hit Control, click to define where your reference point's going to be, and you just start clicking over top of where your dust bunnies are.
Wow.
It's much easier to kill the dust bunnies that are like not on your nebula, because you know, I can just kind of hide this with some background and nobody's the wiser.
Whoa. That's crazy.
And if I duplicate some stars, it's not a big deal as long as I don't duplicate the bright ones. It's going to be like really obvious that I've duplicated areas of the image, right? See how natural this looks?
That was perfect.
You wouldn't even tell.
It was never there. That's amazing.
I kind of have to, I don't want to overwrite the star because that star is real and it's bright, so I'm just going to go right up to the edge of it. And yeah, it's still got a little weird ring around it, but you know, no one's going to notice that when I'm zoomed out.
And it does the area within the circle?
Yeah, so the area inside of the circle is the area that you're copying data onto, and where the X is what part of the image is being copied. So you want to choose an area that has like a similar brightness so that you don't get any weird lumps and lines and stuff like that you can see that are really obvious.
Okay.
Like I'm trying to mask out here and not doing a great job of. Okay, there we go. Yeah, that pretty much gets all of them. And then don't forget to actually apply those, because it's just like a preview of it, and then when you hit the execute button, then it actually applies it to the image. Let's see. I'm gonna apply HDR multi-scale transform. This is it's basically.
I feel like it's ready to go, like ready to go on Instagram. Is it me?
I mean, yeah, it's good. There's a few more things we can do.
Okay, cool.
This is basically a contrast enhancement algorithm. See, I'm just gonna try 7 layers and see how it looks. Alright, so let me blink back and forth to see if I like it. Yeah, see how it kind of brought out a little more contrast in the core there. I'll zoom in so you can see that better.
Oh yeah, let's do it again.
Yeah, just a second. Kind of blinking back and forth between the two. You can see it brought out a little more contrast there in the middle.
Yeah, it's so cool. Love that.
Alright. Yeah, and then I might, you know, tweak curves again a little more. You know, just kind of figure out what I want to have here. I don't want to make the background too black, otherwise it looks really fake, right? So having a background that's not black is actually more natural than trying to make it black like space, especially in the area of these big dusty nebula, because there really is a lot of nebulosity there. So don't make your backgrounds black, because it's not really accurate for most parts of the sky.
I'd like to see the dust.
Yeah. And you know, it's still kind of noisy, so let's do another denoise.
Well, you keep doing it. That's cool.
Yeah, and actually there's some processes that work best before stretching, some that work best after stretching, and some that work best either way. So I'm going to apply that luminance mask again, except now that the image is stretched, I don't have to stretch the mask, this luminance extraction that I did, because it's already stretched, because our image is stretched. Go ahead and apply that. Double check I did it in the right polarity. Yeah. And then I'm going to open up that same denoising algorithm I used earlier. And let's see if it does something that we like. Yeah, that worked all right. The background's a little bit funky, but it's it is what it is. Yeah, and that's pretty much that. And then I'm gonna remove the mask, and then at this point I would save out, go to finals, GC. All right, so this is my let's see, this is attempt number 2 on this target. This is process. This is stack number 2, and the first process of that stack is how I like to name my images. So I'm going to save it in the PixInsight format, and I'm going to save it in the TIFF format. Beware, when you save in TIFF, you need to drop it to 16 bits, or else Windows is not going to show it properly when you open it up in Windows. And then
what would be the advantage of saving it in the PixInsight?
So that I can go back and edit it more later, if I want.
Okay, put it right back in there and just keep going.
Yeah. It saves, it's basically the most raw form of the image without any compression or any like other stuff affected by it. I save a JPEG, it'll give you a warning that JPEGs suck, you hit OK. Yeah, and then I have a JPEG to upload to Instagram. Usually I'll hop over to Lightroom and apply my watermark as well. Let me go ahead and show what weighted batch preprocessor looks like. Let's see, is it still in scripts? I think it's in scripts. So you're going to go to script, batch processing, weighted batch preprocessing. This does the calibration, the weighting that we did during SubframeSelector, the debayering, and the registration all in one fell swoop. You can also have it do the stacking, although PixInsight advises you that you should do the stacking separately so that you can tweak the settings more. So
but if you're just beginning, it really works. It'll get you into the editing phase.
Yeah, it'll make some guesses on settings, and will get you a reasonable image coming out the other end.
Is that what you do, Andrea?
Well, that's what I did to get a quick and dirty thing right off the bat, and then you can get into playing with. It gets you into PixInsight, so now you can apply the curves and the color calibration. As you get more experience, you might say, like Molly does, I don't like these settings, I want to do them manually. But this is like an automated version to get you in fast and functioning.
Yeah, so I select CFA images because these are color images, one-shot color, and I select my Bayer pattern. And then you can, this is where, so like you don't have to set the weighting parameters because it kind of has some presets here. So I can't put in that algorithm that I had, but it has a couple of presets here.
Cool.
So you can just use the presets. You can open up the registration parameters and adjust things if needed. Otherwise, I'll just do the defaults. You can have it, you can adjust the integration, some of the integration parameters as well. Like you can choose your rejection algorithm or just let it auto choose for you. we're just going to let it run on full auto and see how it does. You can have it select, you can check this auto detect best reference frame so that when it does the registration, it will pick the best reference frame. Set your output directory. I'm gonna hang on. Because it's gonna make a bunch of subdirectories and stuff, so I'm gonna make a folder specifically for it. Now, the other thing is that you don't have to, it'll also make your master darks and your master flats for you too. So I'm going to add my lights. Actually, yeah, I'll just go ahead and do the whole thing. So go to add flats, and I'm going to go add my raw flats so that you guys can see how that works. Actually, no, I'm going to use my master flat because I had to do the signal boost on it. So if you have, so what I like to do is once I make my master darks and my master flats, I save them so that I can just, instead of having to restack them every time, it's the same dark and flat, so I don't have to restack my flats and darks every time. But actually I'm going to do this a slightly different way than I have done here because I have flats from multiple nights. So I'm going to hit add custom. And this is why I like to do it by hand because I have to do all this work in WeightedBatchPreProcessor anyway to get all the dates and stuff. I'm going to zoom out just to make it a little easier for me to navigate. So my ones without flats. And then, let's see, I've only done this like once or twice. The ones from the 15th. So what you're doing here is it will match up. Like if you you can put whatever filter name you want in here. This is oftentimes used for if you have red and green and blue filters. But you can also kind of make this whatever you want. So I'm going to call this, let's see, can I use periods? So that when I import my flat frame, I'll call it by the same filter, so that it will connect the two. And I'm also gonna since these are masters, I'm gonna click on this use master dark and use master flat, so that it knows that this is already a master and it doesn't have to stack it. If you have flats that you haven't stacked yet, then you leave those use masters unticked and it will stack them as part of the process. Of course, if you only have one night's worth of data, you don't have to do all this. You can just add your lights, add your flats, add your darks, and go to town. You don't have to specify the binning and the exposure times, but it will auto match up your darks and your flats and stuff if you do it that way. Okay, and I need to add one more, which is the master dark. Actually, I'm just gonna use add darks for that one. Okay. Now hopefully I've got that all added correctly. You can save out an instance of that so that, because scripts, unlike processes, you can't do anything else while the script is open. And you can't always go back and modify parameters later, so I'm going to save this off so that if I need to go change stuff, I don't have to redo the entire thing. All right, you can do a check. You can hit this diagnostics, and it will give you any warnings. Yes, I'm using invalid characters. It'll just take care of all that for me. Let's see. Yep, these are all fine. Then we hit run. It's going to give me those warnings again. It's going to give me a warning about that I'm doing integration, that I should do it separately, but you know, we're going to do it anyway. And it's going to just do everything in one fell swoop, hopefully. It's done. Hang on.
Oh, oh dear.
Okay, so this is the report of how it went. All right, now I have to exit out of this in order to look at my images, which is why I saved the little one down here. So in the weighted batch preprocessing folder, it creates several subfolders. It has your calibrated images, your debayered images, the masters that it made, and all the different registered images. Yeah, so the masters is also where your final images are. Now, oh, okay, it did do that. Because I used different nights of flats for the way that I had to load the different nights of flats to the different data sets, it actually created 4 different, let's see, actually 5 different images. So I didn't stack them all together. Just so the
yeah, like I had a lot of problems with all different nights and sizes.
Yeah. So what I would do in that instance is do it the way I did it, but don't do the integration in weighted batch preprocessor, and then I can just go to the registered images and go to the registration. Go to the image, the stacking, the image integration, and do the integration myself with all of those registered images, because they've been calibrated, debayered, and registered. So just go add all of them from across the different nights. So yeah, so you can do the exact same thing if you have data from multiple nights, just don't do the image integration step in weighted batch preprocessor. Now the bonus of the fact that it does it separately is really handy for when you're using that same procedure to do luminance, red, green, and blue images, because in that case you do want separate ones, because you're gonna you don't want to stack all those together. But in this case of having data over multiple nights, then you just have to integrate it all together.
Yeah.
So you can kind of prettify this image. Oh, it's done. It's done stacking.
All right.
Ooh.
Okay, so here's the rejected high with the airplane and
Whoa.
whatnot. Here's the rejected low. Now, it did not remove frames like we did in SubframeSelector, so this is all 163 frames.
Wow.
But yeah, so that came out all right. And then I would crop
I think
and...
yours was better.
Potentially. It's kind of hard to tell at this point. I would need to do some cropping and, well, do some dynamic background extraction and do some other stuff to kind of see how it came out in comparison.
Yeah,
but yeah, it's definitely a workable image, yeah.
Yeah, right.
So yeah, there's 2 different ways to do it. I think they really take about the same amount of time.
Yeah, because that seems to take longer with the processing.
Yeah, but if especially when you only have 1 night's worth of data, the weighted batch preprocessing can be a quicker way to kind of get a stacked image so that you can start messing around with the other features. Yeah, and actually nowadays in weighted batch preprocessor, you have access to a lot of the settings that you would have if you did it by hand. So
Yeah.
Most people I know use weighted batch preprocessor. I'm one of the only ones I know who doesn't. So I'm sorry that was like really long, but I should have like warned people that it was going to be long.
No,
but
I think you can't help it. It's important.
yeah, there's just so much to cover, and I kind of wanted to do a complete workflow, just to kind of show the whole, kind of demystify hopefully the process a little bit, although I might have made it more mystical. But this was kind of the overview of what it looks like.
Yeah, it's a good overview.
And we can dive into other processes, and I can show, like, a lot of people have trouble with deconvolution, so I can show what needs to be done for deconvolution to work, and what kinds of data it tends to work better on. Cool.
See you later.
All right. Thanks for coming, guys.
Thanks so much.
Bye.
Bye.